Hi and welcome to my maths class. Today we're going to do a revision of all grade 11 analytical geometry. Now, let us start with the basics. When I'm working with analytical, it is basically around straight lines. So when they give you a drawing and they say, calculate the equation of DC. Now, to calculate an equation of a straight line, we know we need M and we need a point. Since we're given 2 points, we can immediately calculate M by saying y2 minus y1 over x2 minus x1. Now when you're calculating gradient, the general rule in analytical geometry is mark your points, substitute and solve. So I'm going to work with DC. I'm going to make this x2 y2, which is marking my points, x1 y1, again marking my points. Then I'm going to substitute into the gradient. So I'll have 1 minus 3 over 6 minus 2. So my M is equal to minus 2 over 4, which is equal to minus a half. Right. Once we have the gradient, we can take any point that we want that is on the line. So I can't be taking point B and point A. It's not on line DC. I have to take point D or point C. And then we substitute into the formula. Y minus y1 is equal to mx minus x1. I have M. I've calculated it as minus a half. So I'm going to have y minus 3 is equal to minus a half x minus 2. To get it into standard form, I'm going to get rid of my brackets and I'm going to bring my 3 over. So I'd have y is equal to minus a half x plus 4. Now let's go over this. When we want an equation of a straight line, I need my gradient and I need my point. You can get your gradient in different ways. Sometimes they give you 2 points. Sometimes they tell you it's parallel. So they can give you 2 points. And when they give you 2 points, you're going to use the formula. Second, they can give you that it's parallel. And when it's parallel, then you know M1 is equal to M2. The last one is they can tell you that it's perpendicular, which means then you know M1 times M2 is equal to negative 1. So to get our gradients, those are our 3 general rules. To get the equation, we know we're going to get y minus y1 is equal to mx minus x1. To get the equation, you basically only need a point and you need M. M is going to come from the 3 steps we have on top. And the point can come from any random place that is touching the line. You can't take a point that's not touching the line. So when I want the equation of DC, I had to get the M, and in this case I used method 1. Then I took a random point. In this case I took 2 and 3 and I substituted it and got it into standard form. Right, the next question says, calculate the equation of AE. Calculate the equation of AE if AE is perpendicular to DC. Now, what are they telling us? If they're telling us that it is perpendicular, then we know the gradients, when multiplied, are going to give us negative 1. We want an equation, and if they want an equation, that means I need 2 things. I need M and I need a point. Now if you look at the drawing, you'd see you have a point that is touching line AE, 6 and 6. So you have a point already. How do you get the gradient? We know that the gradient of DC is minus a half. We had calculated it earlier where M is equal to minus a half. If M is equal to minus a half, so M of DC is minus a half. Since it is perpendicular, we know m1 times m2 is equal to negative 1. So we have negative a half times m2 is equal to negative 1. To get rid of the negative half, we're going to times it by 2 over 1, or you can divide it by negative a half. We'd have m2 is equal to 2. Now an easy way to remember it is to swap it and change the signs. So 1 over 2 topsy-turvy, make it 2 over 1, negative, make it positive. So we have m2 is equal to 2. Now once we got the gradient, we can simply go into the formula y minus y1 is equal to mx minus x1. Now y minus 6 is equal to m is 2. Remember, it is your edited version. This is a very common mistake. Pupils work out minus half, they change it, but when they're using the formula, they still use minus a half. We are not working with the gradient that is minus a half. We are now working with the line that is perpendicular to that one. So it is 2. Open brackets, x minus 6. Now you simply get rid of the brackets and get it into standard form. Take the 6 over and we'd have y is equal to 2x minus 6. Right, let's do another example. Calculate the equation of AB if AB is parallel to DC. Now we know we want an equation, and an equation of a straight line we need two things, M and a point. If you look at the drawing, they are saying AB is parallel to DC. Now at AB we have a coordinate called A, which means that our point is 6 and 6. Now look at the next thing they say. They say that AB is parallel to DC. When a line is parallel to another, we know that the gradients are equal. We have that the gradient of DC is minus a half. If they are parallel, then we know m of DC is going to equal to m of AB. So that means I now have the gradient of m, which is minus a half. Once I have the gradient and the point, I'm going to the formula. You're going to substitute. Your m is minus a half, x minus 6, y minus 6. So we are substituting our 6, the 6 of the y into the y, and the 6 of the x into the x. Now you simply get rid of the brackets by distributive law, and then you make y the subject of the formula, which will give us y is equal to minus a half x plus 9. Now the last part of your summary is inclination. If I say determine the inclination of the line AB. So we're working with AB. Remember, it's not drawn on a Cartesian plane, but you do know the equation of that line. The equation of the line was y is equal to minus half x plus 9. Y is equal to minus a half x plus 9. Now inclination is the same as gradient. So we know m is equal to tan theta. If m is equal to minus a half, then we got tan theta is equal to minus a half. If I want theta, I'm going to press shift tan 0.5, which will give us theta is equal to 26,57. Since it is negative, we know we are in the second quadrant. So we have 180 minus 26,57 degrees, which will give us 153,43 degrees. So our final answer is 153,43 degrees. Thank you for watching.